Buongiorno and welcome to another CheMEMEistry video. Today we're going to look at the reactions of alkanes.
Broom, broom.
Okay, let's do free radical substitution. It sounds complicated, that's because it is.
I don't know what I'm doing.
Now we're going to explain this whole process using our queen Gemma Collins.
Oh, I don't want to play any more games.
Because why not? Alright, so there's three main steps. Right, number one is initiation.
Remember.
We have here a chlorine molecule. Alright, it is usually chlorine, but it can be bromine or iodine. And this is Gemma Collins. She's quite calm at the moment. She's not very reactive, but an outside force, light, hits it. For Gemma, it's the Big Brother house.
Christopher and Gemma are playing with a lemon in a sock.
They separate the two things. Now here, Gemma's been separated from what? Her heated rollers.
Because you've only got straighteners in here, you haven't got heated rollers.
And this makes Gemma very angry, very reactive.
Enough of playing games.
Right? So when the chlorine molecules are separated, it makes the chlorines very reactive. There's methane here. This next step is called propagation.
And remember.
And it's where the chlorine reacts with things that it can find. So in this case, we've got an alkane. So it takes something important to it from someone else. Alright? In this case, it takes Tiffany's shoe.
Come, Tiffany.
Oh, you want your shoes back? The shoes that you... Yeah. I'm gonna give them to you.
Tiffany's shoe is the hydrogen on this methane molecule, and it rips it, and it makes HCl. Alright, so we've made hydrogen chloride. That's quite exciting. Then it's gone away, but the problem is, now Tiffany is angry.
I don't care.
It's created a free radical in the process, okay? And it's made the CH3 free radical. Well, it goes back and it takes something important to Gemma. It goes to this Cl2 molecule, and it takes a Cl off it. And now we have a CH3Cl, another really stable molecule, and it goes. But what else do we have? Well, it's taken the Cl off, okay? And now Gemma's angry again.
Had enough of playing games.
Again, we have the Cl, and that's why this propagation step keeps going round. It creates the chain reaction because the Cl free radical is still there at the end. So it goes and reacts with Tiffany, and Tiffany goes and reacts with Gemma, and it keeps going on until a termination occurs. Now, termination can happen in three ways. Number one, Gemma finds her heated rollers again. The Cl and Cl go back together and they make a nice strong bond. Another way, Tiffany finds another Tiffany. They chat, and that creates an ethane molecule. We have a CH3, a CH3, we have C2H6, and that's stable, okay? Or we have a Cl free radical, which is Gemma, and a CH3 free radical, and they go together, they bond. And sometimes, you know, they can be friends. And that creates our desired product, the chloromethane. So we produce the HCl and we produce the CH3Cl molecules.
The flavor.
And then at the termination, three different things can be produced. We have initiation, where Gemma is separated, propagation, where she reacts with Tiffany, Tiffany reacts with her. So let's memorise that equation. And then we have termination, where everything is fine again.
And remember.
These reactions, they can cause problems.
You need to stop everything.
In the atmosphere, we have a molecule called ozone, O3. Now, ozone can react with a chlorine-free radical. The chlorine rips an oxygen off and it creates O2, and it creates this. It's called a ClO free radical, and this ClO free radical can go and slap onto another ozone and makes two more oxygen molecules. And here the chlorine free radical acts as a catalyst to the rest of the ozone breakdown, because
Don't even act like you know what I'm talking about.
it's produced at the beginning and stays there at the end, so we can keep going round. And this is a problem because we need ozone. Ozone absorbs a lot of sunlight, and if it wasn't there, we'd all die.
You can't.
I've been CheMEMEistry. Thank you for watching.